Today we're going to learn about solving quadratics by factoring. And the whole point of this is to solve for the roots of a quadratic equation. So essentially, we've done some graphs in the past where, let me just reference back to those graphs. For instance, this one we did in the previous video. When we solve by factoring, we're finding the roots, which are the points where the graph touches the x-axis. So instead of looking at a graph, we can do this by factoring, which is another skill we should probably know the basics of from Algebra 1, especially if you had the amazing Algebra 1 teachers here at the Excel Center. So we'll just do some of these, and then as always, if you have additional questions, please let me know. Sometimes you'll have expressions that are already factored. So you can tell that it's already factored because it'll have these two parenthesis sets. So if I know that this expression multiplied by this expression, because there's no plus or minus in between, I know it's multiplication, this times this equals 0. That means that one of these has to be 0. So that means I can take x minus 2 and set it equal to 0, and x minus 1 and set it equal to 0. This is my favorite type of problem because it's already factored for you, and all you have to do is get x by itself. So we'll add 2. The opposite of a negative is adding, and here we'll add 1 to both sides. So that means that if this were to be worked out as a graph, this graph would touch the x-axis at x equals 2 and x equals 1. We also refer to those as the solutions and the roots of the quadratic equation. Now you'll see the rest of the problems on our note sheet are not factored. So that's all right. We can break out our factoring toolkit so we know different methods of factoring, such as greatest common factor. There might be a number that all of the coefficients can be divided by. You might break into your big X, which is where we find the numbers that multiply to the guy at the end and add to the one in the middle. So we have a few different skills in our toolkit. The key thing is if your expression is not factored, you still need it to be set equal to 0 before you can start factoring. So you'll notice this one is set equal to 0, so we're good to go. You can kind of ignore the 0, cover it up, whatever helps you. We're going to be looking at factoring this expression right here. So a lot of us do the big X, some of us don't. You can use it or you can lose it, whatever works for you. The number at the back, that very last number that's by itself, that will go on the top of the big X. The number in the middle will go on the bottom. And just remembering the big X is just a way to solve, excuse me. So we're trying to find numbers that multiply to the top or the back number and add or subtract to the bottom number. Usually I just write a little plus in the middle. So you can use the big X as an organizational device if you like. So we know there are only two numbers that multiply to 5, and that's 5 and 1. Doesn't matter which order you put them in. But you also need those two numbers to add up to -6. We know if they are multiplying to a +5, they have to be the same sign. So they're both positive or both negative. If they're both positive and I go into my calculator and I do a +5 times a +1, I will get a +5, which is awesome. But 5 plus 1 is not -6. Now, if I go into my calculator and I do a -5 and a -1, that does add to -6. I want to show you briefly how to do that in your calculator. You want to use this little button down here, -5 plus -1. And it should look something like that. There's a little glare. And so that's how you can use the addition. If you're using subtraction, you would just do -5 minus 1. So either of those would work out. So to write your answer, we're going to go to our two parentheses. Well, really our next step, because we have to get something that looks like this. So just like over here, it's got x and x, the variable is b squared. So we're going to need a b and a b. We know that when we multiply, we add exponents, and these both have an invisible 1. So that's why it would get you the squared. And then you'll put your numbers in your parenthesis. So your -5 and your -1. Now you have something here that's factored. So we have a factored expression. We can set them both equal to 0. Now this last step, you can show the work like we did over here, or we can do this one-step equation in our head by doing the opposite. So since it's a -5 over here, we know b has to equal 5. And a -1 over here, b has to equal 1. So that's a little shortcut trick. Also, if you're kind of running out of paper. Now, when we look ahead to number 3, what's different about number 3 versus number 1 and 2? Well, it's not factored for 1. And then also it's not set equal to 0. So these problems will only work if it's set equal to 0. The reason for that is, if you remember from Algebra 1A, those equations like y equals mx plus b, or y equals, when you're doing a graph, y equals 5x minus 4. When you're trying to find the x-intercepts of a graph, the y value has to be 0. So this number over here, this 0, symbolizes y being equal to 0. So you need this side to be equal to 0. I usually say to people, if the squared term is on the left, you want to move everything else to the left. It's going to make your problem easier to factor if that squared number is positive. And all the ones we do in this class will be like that. But if it's ever not, if you're taking a standardized test, or if you just happen to encounter that on an Ivy Tech prep test, just getting that to be a positive by moving everything to the opposite side. But fortunately, you won't have to deal with that here. So if we wanted to get this 4 over to the left, you can even think of that popular Beyonce song. Okay, maybe for you guys, it's not that popular anymore, but to the left, everything I own in a box to the left. Very cheesy, but it works. We want to move this 4 over. Since it's positive, we're going to subtract it and make it negative. So it's x squared plus 4x, and 8 take away 4 is positive 4. And that is set equal to 0. So step 1 is always set it equal to 0. Second step is to factor. So since we have our just solo x here, we can do our big X. We'll usually have 3 terms here, but if you don't, you can always insert in a 0. We'll do some like that here shortly. So we have positive 4 at the end, so we'll put a positive 4 at the top and a positive 4 in the middle. So we also have positive 4 on the bottom. So we're looking for numbers that multiply to 4 and add or subtract. I'm just going to write a plus sign to 4. Sometimes it's helpful to make a little factor list. So I've seen people make a little list of numbers that multiply to 4. And that sometimes helps people. So like 4 times 1 and 2 times 2, you can use a multiplication chart, or you can divide in your calculator. So since we want these 2 numbers to multiply to 4, but also add to 4, we know it can't be those because those add to 5. If I put a 2 and a 2 here, though, 2 times 2 is 4, and 2 plus 2 is 4. So I can go right to x plus 2, and x plus 2 equals 0, because x times x is x squared. And you could even check this by doing x times x times 2x, or x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. And we know that 2x and 2x equals 4x. The cool thing about this one is these are the same, so you only have to do it once equal to 0. That means you only have one x-intercept. x equals -2. The way I like to think about that graph is that graph would hit the x-intercept and then it would hop back up. We know it's opening up because it's a positive x. Good. In this case, you did have like terms you could combine. So when we brought that 4 over, it combined really, really, really nicely with that 8. That doesn't always happen. So like with number 4, you'll notice there's no like terms over here. So when you bring these numbers over, you're going to have to carve out a space for them. So this will become a plus 9b and a positive 18 when they come over, because that's how we're going to get them to cancel with the top numbers. Now, it's kind of like what we did on our formula sheets in the beginning. We always want to have that x squared term in the beginning. And this is on your formula sheet. Your bx in the middle and your c at the end, your constant by the number that's by itself goes last. So it's the same kind of flow here with a and b being coefficients. So we'll have b squared first, and then would the 18 or the 9b go in the middle? The 9b, that's right. So we'll put the 9b in the middle and we'll put the 18 last. And now it's set equal to 0. We just had to carve out a little bit of space for those terms to go in. I know these aren't x's, so that can be a little bit on the confusing side, but it's always whatever variable is with the squared goes first, whatever is just the solo one with the variable goes in the middle, and the constant goes at the back. We can do a big X for this one, or we can do a factor list. It's really whatever works best for you. So we're finding numbers that multiply to 18 and add to 9. So just think on that for a second. Okay, good. So if you really struggled to find your numbers there, you could go in your calculator and you could divide 18 until you get two numbers that add or subtract. So 18 divided by 2 is 2 and 9. Those don't add and subtract to 9. 18 divided by 3, 3 and 6. I know off the bat 3 and 6 add to 9. So now I can just check my signs. So I know that 3 times 6 is 18. So that works out nicely because it's a positive 18. And I know 3 plus 6 is equal to 9. And I wouldn't want to make those negative because a negative 3 plus a negative 6 is not going to work out to get me a positive 9. So we can go right to our final answer. B plus 3 and B plus 6 equals 0. We can do our opposite signs here. So we can make this a B equals negative 3 and B equals negative 6. Beautiful. So a lot of them will have like terms, some of them won't. So when you're looking through your problems, just make sure you check for like terms, and the ones that don't have like terms, don't worry about too much. So for this one here, this one's very similar to some of the other ones we've done, but just to make sure you kind of got the setup of it, I'm going to show it to you just so you have it. But if you want to skip over this one, you totally can. So draw your line. You see the p squared is positive on the left side. So we want to bring this 8p and this 1 over to the left. Since it's a negative 8p and we want to cancel out, we're going to make it a positive. And a positive 1 we want to cancel out, we're going to make it a negative. Just pop those right over there on the other side. And then use your calculator to solve it. So we have p squared, we have negative 15 plus 8, which is negative 7p. Our ones will cancel, and then it's equal to 0. I'm actually really glad we did this one, because sometimes what'll happen is you'll bring a number over and your not coefficient, but your constant can actually cancel. So if this happens for you, you want to look really carefully at what type of factoring this is. And that's what makes these a little tricky sometimes, is they're not all 100% the same. You'll notice number 3 and 4 had 3 terms. And this expression has 3 terms. So it's really nice when we can do the big X. This one, you can't really do the big X because it doesn't have a constant. I mean, you probably could do it that way, but it would take a bit more effort. So for this one, you want to look for a greatest common factor, which you technically always want to look for a greatest common factor first. There just didn't happen to be one here or here. So when you look at these, you might be like, that doesn't make sense. Like this one doesn't have a number and this one has a 7. So what's the greatest common factor? Well, they both have p's. So you can divide them both by p. You can put a little 1 with that p. When you divide exponents and they're stacked, you subtract. So P2 and P1 divided is just P1 or P. And then over here, the P's cancel. So that's -7. Since we divided by P, we want to put that P out front. And now it is factored because we have our answer with parentheses. So we can set both of these equal to 0. The first one is nice because it's just P. No solving there, just P equals 0. The second one, you would do opposite because you have to add that 7 over and it'd be P equals 7. This one tricks people sometimes. So just remembering if there's not 1, 2, 3 terms, you really want to divide by whatever the variable is. Since they both have at least 1 P, we can divide by P. And then sometimes there's a number that goes into both. Number 6 is really close to 5. So this will be extra practice on number 5. And the worksheet ones are pretty similar for the practice. So if you looked at number 5, you have to ask yourself, is it set equal to 0? So what do you guys think? Yes, it is set equal to 0. Do 5 and 4 have a number that they can both divide by? So like, does 5 divide by 4, 4 divide by 5? Okay, 4 divides by 2, but 5 doesn't divide by 2. So we can't really divide by any number. They both have at least 1 X though. So we can divide by X. This one's a little less work because it's already set equal to 0. We can put a 1 with the X if that makes life easier for you, even a little exponent of 1. Sometimes that muddies the waters for people. So just ask yourself, what's going to make my life a little easier here? 5 divided by 1 is just 5. And then one of the X's will go away or cancel. And then here, these X's cancel. And that leaves me with a -4 equals 0. If this part confuses you in the beginning, I've also seen people write it out like this. There's 2 X's on the top, 1 on the bottom, and one of them cancels out. So it leaves you with the X. That might help. Just remember to put your GCF on the outside and X. And then from here, when it's factored, you can set X equal to 0. That one's done. This one here will require a bit extra. So 5x minus 4 equals 0. Here, you'll have to draw your line and you'll have to get X by itself. So we'll add our 4 over. So it's 5x equals +4, not -4. And we know that 4 is not divisible by 5. So we'll just leave it 4/5. If you don't like fractions, you can make it 0.8. I believe that is good. So a lot of these are pretty similar once you set them equal. I do want to point out that sometimes you'll have problems that have a greatest common factor in front. So I want to skip down to number 8. So it's not equal to 0. So we're going to set it equal by adding that 4 over. That 4 cannot combine with anything. So we're going to carve out a space. That space will be at the end because it's a constant. Now you might notice here, you have 3 terms, which is beautiful, just like the top ones. But there's a number in front. So when there's a number in front, you want to see if it has a GCF. So let's try to split these down by 4. I don't know why I wrote a P there. So these 4s will cancel, leaving you with p squared. 8 divided by 4. Well, -8 divided by 4 is -2. And 4 divided by 4 is 1. And we want to remember that there is a 4 out front. This one's a tad on the tricky side. It still has a p squared, but you guys are really smart, so I know you can do it. If it has a p squared, you want to do your big X and put your 1 on the top and your -2 on the bottom. So if you don't do big X, you can just find what multiplies to 1 and what adds to -2. There are only 2 numbers that multiply to 1, and that's 1 times 1. You may be asking yourself, well, how in the world is 1 and 1 going to get me -2? If I made both these negative, they still multiply to a +1, correct? Yeah, -1 times -1 is +1. Now, -1 plus -1 is also -2. So I'm going to carve out a little bit of space. I ran out just down here. So we're going to keep our 4 out front. And we're going to put our p minus 1. And p minus 1 equals 0. This is nice because we know 4 cannot equal 0. So you don't have to worry about the 4 since the number 4 is not 0. And we only have one factor we need to set equal to 0. If we add our 1 over, we get a +1. So the good thing is about this one is you only have one solution for all that work. It was multi-step. You set it equal to 0. You had to divide by a greatest common factor. And then you did the big X. So it is a lot of steps. And there's one more you can practice like that at number 9. So we're going to look at number 10. This is the last one we're going to do today. I know factoring is a lot. I'm going to have you guys practice on your own as well. So we have k squared minus 32 is -7. So we want to bring that -7 over. The really good news here is there is a like term that you can put it with. You can put it with the -32 since they're both constants. So I end up with this k squared minus 25 after I add these two together in my calculator. You'll notice this problem doesn't have that middle term, that k. So what you can do is you can go ahead and rewrite this with a 0k in the middle. This is just how I do mine. It makes life a lot easier for me, but if you have a different way, please feel free. So I'm finding numbers that multiply to -25 and add or subtract to 0. I know the only numbers that multiply to 25 are 5 and 5 or 25 and 1. And I know they have to be the same number because there's a 0 down here. So they have to cancel. That means if they have to multiply to a negative, what do the signs have to be? 1 positive, 1 negative. Good. And then 5 minus 5 is also 0. So I'll have k plus 5 and k minus 5. Doesn't matter the order you put them in. And then I know it's in factored form, so I can set both of those equal to 0. But since I don't have a lot of space, I know that it's just the opposite of those two numbers for my roots. So my two final answers are 5 and -5. Anytime you have something like this without that constant term in the middle, or without that linear term rather in the middle, because this is the constant, you can go ahead and insert that 0 in. Know that these two numbers are going to be the same and opposite sign. So I have a practice sheet you can practice on. We'll spend a majority of today working on factoring. If you didn't have Algebra 1 for a while, this might seem a little rusty, and you might need to ask additional questions, and just know that's a-okay. Have a great rest of your day. Thank you.